Let's examine some additional factoring techniques. When we have exactly two terms, and it is a difference of the two terms, and both terms are squares, this can be factored as the difference of two squares. So yes, this was a difference. The first and last terms are squares. We want to take the square root of each term and place them in the binomial. So the square root of 9c squared is 3c. Put it first because this term was first. The square root of 64 is 8. Put it last because this term was last. Automatically connect the first pair with a minus sign, connect the last pair with a plus sign, and you are automatically correct and finished. The next problem we're going to look at happens to be a trinomial, but it's a special case trinomial. I know it has a leading coefficient that's greater than 1, but if we see this special case, it's going to be a little quicker to factor. We have three terms, meaning a trinomial. We want to find the square root of the first term, which is 9. Square root of 81 is 9. Find the square root of the last term, which is 4r squared, and that square root is 2r. Are the first and last terms positive? Yes, they are. Take the product of these two square roots, would be 18r, double it, and if doubling it gives you the middle term, then this is a perfect square trinomial. Put the square root of the first term in first, the square root of the last term last, and whatever that connect middle sign is, that's the sign you put down, sign of the middle term. That quantity is squared. This is a binomial squared, which leads to a trinomial, perfect trinomial square. We now reach the stage where we want to solve, not factor, but solve equations. We're going to use the factoring as the process. Well, first let's undo the multiplication. So we're going to FOIL this. 4t squared plus 24t minus 6t minus 6 equals minus 21. The only technique we have right now, if we're quadratic means the highest power is 2, is to bring all terms to the left. And when we do that, we get 4t squared. This combines to give plus 23t. When the minus 21 comes over, we get a total of plus 15, and that's equal to 0. So if we have a quadratic equation, power 2, which is equal to 0, if we factor this and then set each factor to 0, we'll be able to come up with the solutions to the problem. So again, I'm using that technique I showed you a moment ago. Take 4, write it as 1 and 4, 4 and 1, and 2 and 2. Take 15, write it as 3 and 5, 5 and 3, 15, 1, 1 and 15. And then we like to form inside and outside products to see if I can get 23. The inside product here is 12. The outside product there is 5. 12 and 5 does not add or subtract to give 23. Try this with this. The inside product is 20. The outside product is 3. That can add up to 23. So that is the right combination. 1 and 4 go first in the binomials, 1t and 4t. 5 and 3 go last in the binomials. Now we need to choose the sign for the middle term. We see that the inside product is 20t, the outside product is 3t, and if I make them both positive, we can get a total that's 23t, and if we multiply the last terms, plus 5 times plus 3, we get 15. Since we have a product equaling 0, the conclusion is that either of these factors must be 0 for the product to give me 0. So we set t plus 5 equal to 0, solve, t becomes minus 5. Set the factor 4t plus 3 equal to 0, solve, 4t equals minus 3, t equals minus 3 quarters. So the solutions to the original problem, which means they balance the equation, are that t could be minus 5 or t could be minus 3 quarters.